Next, I want to talk about geologic time. So the Earth has changed over a very long period of time. The Earth is about 4.6 billion years old. And so we need a way of dividing up. That's a very long time. And what scientists do is use rock formations and also the fossil record to break this up into what's called the geologic time scale. And this is a hierarchy hierarchical way of organizing time periods into intervals. So we start with the biggest ones, which are eons. Eons are broken up into eras, and those eras are broken up into periods, and those periods are broken up into epochs. So just to kind of cut to the chase, we are currently in this thing called the Phanerozoic eon. That's about the past 541 million years. And we are also in the Cenozoic era. So the Phanerozoic can be broken up into three parts: the Paleozoic, which is before the dinosaurs; the Mesozoic, generally the time of the dinosaurs; and now the Cenozoic, this era after the dinosaurs. And within that, we are in the Quaternary period. That's about the last 1.8 million years. And the Quaternary can be broken up into two parts: the Pleistocene, which is the Ice Ages, and the Holocene, which is a modern, warm, stable period of about 10,000 years. So let me switch over to this thing called chronozoom. Chronozoom is, one thing when we show those figures that break up geologic time, they're not to scale. So I want to just kind of review this just to give you a sense of scale. This is showing the cosmos, which is about 13-point-something billion years old. And here we have the Earth and the solar system, which is about 4.6 billion years old. And we'll use the life scale. It's one that breaks it up into different parts from the fossil record. So we have this very ancient one, the Archean and the Proterozoic, and we're mostly going to be looking at the Phanerozoic period, the Phanerozoic eon here. Okay. The Phanerozoic can be broken into three parts, as I mentioned: the Paleozoic, which is before the dinosaurs; the Mesozoic, which is sort of the era of the dinosaurs; and the Cenozoic here. And you notice that these are kind of getting smaller and smaller as we go. And so the Cenozoic is fairly, fairly recent, about 66 million years. And we can kind of look over here, and we talked about we're in the Quaternary period, this little bit here. The Quaternary period, most of that is made up of the Pleistocene. This is a couple of million years of ice ages up till about 10,000 years ago. We got to zoom in really tight here to find the Holocene. Now, humans have been around before the Holocene, but most of recorded human history, ancient civilizations, agriculture, is confined within this period called the Holocene. This is the past 10,000 years roughly where we've been out of the ice ages and had a relatively warm and stable climate. We've had development of civilizations and agriculture and all that sort of thing, but if you zoom out, you can see that that's just a pretty small bit of a much larger time period. So let's zoom out now. It's Phanerozoic. And for life on Earth, you can't even see it. It's just a tiny little bit. So, so when we see a figure like that, just bear in mind that it's not to scale. So we have to we tend to amplify the stuff that's more recent because it's a stuff that we tend to find more evidence of because processes have kind of covered up much of the past. So a couple of concepts that are related to geologic time. One is uniformitarianism. That's the concept that the present is the key to the past. And this is the idea that the processes that are happening today are what created things like the Grand Canyon, for example. Now, when people didn't know the age of the Earth, people assumed that big catastrophes had to happen, like some major flood or some major event had to create things like the Grand Canyon. But with knowing how long the Earth has been around, what we know is that that's not the thing. The Grand Canyon wasn't created all at once. It was created very slowly, but over a long period of time. That being said, what we tend to have is where we have a lot happening and then little happening. We have periods of stability, punctuated by periods of rapid change. And one example of that is an orogeny. And orogenesis is about mountain building. And so when there are those time periods when there's a lot going on and mountains are being created, we call that an orogeny. So for example, we might refer to the Nevadan orogeny. This is a time period when the Sierra Nevadas were being built up. And related to plate tectonics, one thing I'll mention is that over this geologic timescales, the continents actually move because they're constantly in motion, being spread apart, pushed together. So about 200 million years ago, we had Pangea, where all the continents were together. Then over time, that broke up into the separate continents, and they continue to evolve and to where today the continents are where they are, but these have been in motion over time.